a Wi-Fi 6 point-to-point bridge that takes over automatically when fiber fails. Hi tech lovers, welcome back to Fast Cabling. So today we're saving a business from downtime. We have two sites, 2 kilometers apart. They've got a fast fiber link between them, but it keeps going down. One physical path means one point of failure. If that glass breaks, get bent, or someone's digging a trench, you're out. And repairs takes hours or even longer. So we're giving the path a second way around through the air. We're adding a wireless backup, so when the fiber fails, nothing stops. So let's get straight to the build. So here's our client's current setup. Fiber link from site A switch to the site B switch. Now when this link is up, apps fly, ERP, VoIP, CCTV, but when it drops, phones go silent, video freezes, tickets pile up. So our fix is a Wi-Fi 6 point-to-point bridge that takes over automatically when fiber fails. No digging, no permit, just 2 radio with directional antennas. And it's a fraction of the cost of laying a second fiber, and we can install it in an afternoon. And our wireless bridges uses Wi-Fi 6 technology with 2x2 MU MIMO and OFDMA. It has a gigabit Ethernet IP67 weather sealing and is powered by PoE. It supports up to 15 kilometers line of sight range and up to about 900 megabit of throughput. So it's plenty for our 2 kilometers hub. So now let's mount it on the demonstration board. Our wireless bridges and PoE injectors are already on the demonstration board. So let's begin. By adding it, we have to use an Ethernet cable connect from our 24-port managed PoE switch to the injector's data port. Then use another short patch cord connect to the PoE port. So we can send both power and data through a single Ethernet cable to our wireless bridge. So on the back we can see the indicator lights are on. Now line of sight is king. There should be no trees, no buildings, no metals in the way, and we can start by pointing both antennas generally at each other, then fine-tune using the signal LEDs on the back or the web UI's interface. Now think of it as an invisible wire. Each side has a directional antenna. They log on, form a secure link, and pass Ethernet frames just like a cable. On this side, we're doing the same thing. Use a short patch cord, connect from the wireless bridge to the PoE port. Then, another Ethernet cable from the data port to the managed switch on this side. So now our switches will see it as a second uplink. The physical connection is done. Then we need to configure. I already did. We need to set one unit as master and the other as client. Match the band and channel, set the same channel with SSID and security. And for a clean spectrum, you can pick 6 GHz channel if your region allows. Then you can confirm link status in the dashboard on the web interface. Oh no, where's my video feed? Seems like the system is not working. Maybe I need some help. So here we have our tech specialist, Joe. So Joe, I'm trying to create a redundant system by adding this wireless bridge, but after I plug it into the switch, the system is not working. I wonder why.
Have you configured the port aggregation?
Oops, not yet.
I think I know the issue. We are not allowed to use 2 cables to connect 2 switches directly. It will create the dead loop and crash the whole network.
I see.
Even this is the wireless connectivity, but from the switch's perspective, it is another independent link. Now we have 2 links connecting to these 2 switches. It is not going to work.
So we have to aggregate the 2 cables into one.
You're right.
Okay.
You know how to run the port aggregation, right?
Yes, sure.
Just make sure you pick the port with the same speed to run the aggregation. you probably need another SFP slot to run the port aggregation.
All right, I got it. Thank you very much, Joe.
Welcome.
Thanks to Joe, now we know what happened. Two links between the switches form a dead loop and broadcast storm, and the solution is link aggregation, also called LACP, where we bundle two ports into one logical pipe. And next, we'll build an aggregation group so our switch treats fiber and wireless as a single logical link and avoid broadcast storm. But keep in mind, you need managed switch that support link aggregation on both sides. Now let's unplug our Ethernet cable that's connected to the wireless bridge. Because we have to use the ports with the same speed, that means we need to use the SFP slots next to the fiber optic cable. But how? The copper to fiber SFP transceiver. Just slide it into the SFP port, and now we can connect the Ethernet cable directly to this SFP slot. Perfect. And we're doing it on the other side. Unplug the Ethernet cable connects to the wireless bridge, slide in our fiber to copper transceiver, then plug in the Ethernet cable again. So the physical connection is done. Next, I'm going to bring out my laptop and configure link aggregation. So I already set the link aggregation on one side of the switch. Now I'm going to set it on the other side, already connected to the laptop. First, you need to make sure your laptop and the switch are under the same subnet. Then you can type in the IP address of the switch and log in. After we log in, we can see the sidebar here on the left. We need to select port channel configuration, then LACP port group configuration. Let's create a group number, let's say group number 2. Now we need to add member to this group. We're using port 27 and 28, so let's choose 27, add, and 28, again, add to it. So now we created the port group, and let's wait for a second. But before you go, make sure you hit save and exit. And now let's see if the bullet camera is up. So now our system is calm. So time for the moment of truth. We are going to simulate a fiber cut. Now I'm going to unplug our fiber optic cable. You can see it's disconnected. I'm going to see if our bullet camera works. Our CCTV stream still running, and the traffic leads to the wireless bridge here. If we plug the fiber cable back in, it rebalances. So throughput depends on distance, channel width, interference, weather, and alignment. And a safe rule for planning is to divide the labeled speed by 3. If the spec says 900 megabit, you should plan for roughly 300 in day-to-day use at distance. And that way, you're never surprised. So today we kept the fiber as primary, added a Wi-Fi 6 bridge as backup, fixed our loop with link aggregation on managed switches, and proved failover works. No trenching, no permits, just uptime. Thank you very much for joining us. If this video helped, please don't forget to subscribe and tell us what backup you want to see next. And I'll see you in our next video.